Alright, so here's how to solve the first problem on the review guide for the quiz tomorrow. We've got the standard enthalpy, or delta H, for 1 mole of strontium carbonate, the stuff that gives red fireworks their color. And the formula, or the equation, is 2 strontiums plus 2 carbons plus 3 oxygens gives 2 strontium carbonates. Here's our information that we're going to use to calculate our delta H for the given problem here. So what I try to do is find things that are kind of unique to this equation up top and one of these 3 equations down here. And if you notice, I have strontium here, and the only place I have strontium as the element is in this first equation right here. And what's nice is I've got 2 strontiums in my sample problem, and I have 2 strontiums in my my first equation here. And over here, strontium's a reactant, as down here, so that means that we don't have to do anything to this equation. I'm just going to recopy it. 2 strontiums. And since we didn't have to multiply it or change the direction, the delta H for this equation is going to go unchanged, and that's going to be negative 1184 kilojoules. Now I'm going to go look at what other information, so I can kind of check this one off. I've already used that one. I can find out what other information I have up here can I get from here. And if we look at our second equation, looks like I've got strontium carbonate here, and I've got strontium carbonate here. What's nice is it's a product here and it's a product here, so I don't have to switch signs or change the direction of this equation. But I've got 2 of them up here in our equation that we're trying to find the delta H for, but I only have 1 of them down here. So that means I've got to double this whole second equation. So I'm just going to rewrite it as is, only doubling all of our coefficients. As I said, doubling all of our equations. And my delta H prime, or I'm sorry, delta H0 for that, is going to be 2 times negative 234 kilojoules. And now for our last one, I've got 2 graphites as a reactant. Let me cross that guy off. And then a graphite here is a reactant. So I'm not going to have to change the direction of this equation either. I just have to double it. So I'm just going to double that last equation. I'm not going to spell out graphite. We'll just call it carbon as a solid. Plus 2 oxygens is going to yield 2 carbon dioxides. And my delta H for this, delta H naught, is going to be negative 394 kilojoules. So now just to see what can cancel out, if I've got something on both sides of the equation, I've got equal amounts, I can cancel them out. So I'm just going to try to see what can cancel to get me this equation here. It looks like we have 2 strontium oxides here, so they're going to go away. We have 2 carbon dioxides down here, and they're going to go away. And here we've got the only things left are the things that I'm looking for. I've got 2 strontiums, I have 3 oxygens, I have 2 carbons, and we're going to make 2 strontium carbonates. So everything that I need is still with us. So all I'm going to do is sum these together. I'm going to take negative 1184 plus 2 times negative 234 plus negative 394 kilojoules. And if my calculations were correct, which I'm hoping they were, I should end up with negative 2,440 kilojoules. So again, this problem, we just want to make sure, cross that guy off too. We want to make sure that all of these equations here are lined up in the same direction, so that if we're looking for what's going on with our reactants, we should move these so that what we have as reactants up here will be reactants for these equations down here. And if we have to multiply it by some number, the coefficients by some number, we're just going to have to multiply our delta H pluses on this. So hopefully this clears things up for some of us. And we'll take a look at number 2 in just a second.